Alright, so today we are talking about area of non-right triangles and Heron's formula. So, as you've noticed before, we are moving away from what you did in geometry with right triangles and progressing into non-right triangles. That also includes area, okay? Do you guys remember the formula to find the area of a right triangle? Which one? One half. Base times height. That was the area to find a triangle. That's what you guys know now. Okay. After today, you will know how to find the area of any type of triangle, whether it's right or not right. Okay. So here's an example just to refresh your memory. What's my base? 6. My height? 11. Does it really matter? No. This is a right triangle. It's universal. So what is my area? 33. And you cannot forget your units. Meters? Squared. Squared always goes with area. Cube goes with volume. Okay, so do not forget your units here. We're dealing with area. Okay? But now we're going on past right triangles, okay? Yesterday, we talked about two situations with law of cosines where you have side, 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 and side, angle, side. Okay? Two different situations where we use two different types of formulas. Same applies for area. When you know all three sides of a right triangle, you use something that's known as Heron's formula. And Heron's formula, which is not on your paper, you need to write it down, is A equals the square root of S times S minus A times S minus B times S minus C. What is S, you're wondering? Well, S is known as the semi-perimeter, which is basically the sum of all your sides divided by 2. Okay, this comes from the olden days. Heron of Alexandria was the one who came up with this whole concept, okay? They took non-right triangles, they found a relationship between all of your sides to help find the area of any triangle. And that's where you get your semi-perimeter. How did someone come up with that? For real, genius. And also a lot of trial and error, too. A lot of trial and error. Okay? Honestly, guys, it really is just that simple. You have the formula, you know how to find S, and so you just plug it in. So here are all your sides. Yes, your triangle is not labeled A, B, and C, but it really doesn't matter because you're subtracting each side from S. Okay? So let's find S. It is half the sum of all your sides. What's 8 plus 5? And what's half of 21? So S is 10.5. You gotta find that out first. You can't do Heron's formula without figuring out S first. So then you just go in and you plug it into the formula which says S times S minus A. Again, it doesn't matter which side you make A, which side you make B, which side you make C. Because at the end of the day, you are still subtracting every side from S. And taking the square root. So you type all this into your calculator, you take the square root, and that is the area of this triangle. So I'll give you guys a second to type that in. So you get about 18.998. We'll round it to the nearest hundredth, and so that rounds up to be about 19. Can't forget R. Can't forget R. Units.
I did not get that.
And then you square it. Okay? So you're going to try example 3. You guys are trying example 3 to get the area. What you guys get for S? S? 19. And so the area is about
58.48 yards squared.
Yeah. You did not get 58.48. So you use Heron's formula when you have all three sides. But then there was the side angle side situation. Okay, if you thought Heron's formula was easy, this one's even easier. Okay? This one doesn't have name, okay, because it's the one that's used honestly the most often, even more than 1/2 base times height. This is how you find the area of a triangle when you're given two sides and an included angle. Now before you guys get confused with like, this will be easier. Yes, it is, because you guys, these are the same formula. Okay, just like with the law of sines, how there were like the 3 different formulas, except if you were looking for side A, you had that, and you look at side B, you had that one. It's the same thing. You would use this formula if you were given side A and side B and given angle C. You would use this one if you were given side A, side C, or you were given angle B, and so on and so forth. But honestly, it's the same formula. It's the same formula. So really, you only need it one time. I just wanted to show you all of them just in case you're like, well, wait a minute, we're given side B and side C and angle A. How do we use that? You know, y'all hit me with that. So, but it's the same formula. Half your 2 sides, sine of your angle. And it works every single time. Let's do this problem. What are my 2 sides? A and C, which are 5 and 8. And then we take the sine of our angle, which is 71. And we type it into our calculator. And we get our area. And we get about 18.91 meters squared. And that's it. Just that simple. Units are always squared. It's always squared units. Do example 5. Do example 5. So this was easy, right?
Yes.
1/2, 6 times 14 sine of 55. What'd you get?
Why do we put in square? Why though?
Because you always put your units. It's always squared units whenever you're talking about area.
Well, those aren't square.
But we don't actually square the numbers themselves. No, we just the units.
I thought it was finding the other side.
No, we don't. I mean, we could. That is one option we could. We could use law of cosines to find this 3rd side and then use Heron's formula. A little longer, but that's okay. We still get the same area. Okay? But now that formula to find the area you could use for any triangle, right or non-right. And I'm going to show you. Go back to the front. And equilateral triangle. Go back to the beginning. Use that same formula for this triangle. We would set it up as 1/2. What? Type that into your calculator. And you get 33. Yes, you will get 33. The reason why, type this into your calculator. Type just that part into your calculator. It's 1. That's why this works for a right triangle, because the sine of 90 degrees is always 1. You guys remember the unit circle?
Yeah.
Remember when we did that and we did all the degrees and all the ordered pairs? 90 degrees, sine was the y coordinate. It was 1. That's why this works for any triangle. That's why this one is the most used out of all of your formulas for area. So you can use it, yeah. So, questions on using area? Because then you would, the reason why you didn't learn that first was because then you would have had to introduce sine, unit circle, and all of that. And it's, baby steps, baby steps. So here we go. Let's look at some more involved ones. All right? It says if the area of triangle DEF is 101, D is 16, E is 14, find the measure of angle F to the nearest 10. And go ahead and scratch this out. I don't know why this is there. Scratch that out. So we use the formula, and let's do that. Let's draw a picture. Triangle DEF. We know side, we don't know D, little d is 16. Where is 16 going to go? Across from D, between E and F. Where is little e going to go? Between D and F, across from E, and we're looking for angle F. We have what situation here? Side angle side, and I know the area is 101, so I know which area formula I should use, right? Heron's or the other one?
Wait, what's that little
Theta. Angle. Just theta, no. Anytime we're looking for an angle, we have the inverse. So plug in what you have. You know the area is 101. You know D is 16.
I gotta go backwards.
And you know E is 14. And yes, you have to work backwards. So what's half of 16 times 14?
112.
I need to divide by 112 first because I have to get sine F by itself. So sine F equals 101 over 112. And again, to find an angle, I have to do the what? The inverse of sine. Making sure I'm in degree mode, I get an angle of 64.39. And that is angle F. So do you see how you use the area formula to work backwards to find angles? You could also do the same thing if they wanted you to find one of the sides. You could do it that way too. It looks like some of you guys are already talking about this one, okay? It's asking you to find the area of the logo. Use a little bit of deductive reasoning and see if you can find the area. I don't want you to shout it out. I want you to go ahead and try to figure it out and find the area of that logo, A, B, C, D. With a raised hand, someone tell me in words, how do I go about finding the area of this logo? Kayla, she is doing this. I got it.
Oh, So you can find the area of the big triangle,
Which triangle is that?
the ABC,
Uh-huh.
and then you find the area of the triangle AGC, and you subtract the area of ABC from ABC, which gives you the area of ABC.
Exactly. You take the area of the big triangle, ABC, subtract from the area of the little triangle, and it gives you the area of the logo.
Alright.
That it does. Which formula did you use? Did you use Heron's or use the other one?
The other one. I use that one.
The other one. So it should have been 1/2 8 times 11 times the sine of 75. That was your big triangle. Minus 1/2 5 times 9, the sine of this angle, 120. And hopefully you didn't round each of these because then you would have a rounded area. Use the long decimal. What'd you get?
Can you type all that in?
Yep. 23.02 centimeters squared. And that is the area of your logo.